Now we're going to discuss the chapter on logistic regression, which follows naturally if we've understood the basic concepts of multiple linear regression. Logistic regression extends the idea of linear regressions to situations where the outcome variable is categorical. It's widely used, particularly when a structured model is useful to explain profiling or predicting whether you're classifying when you're classifying something as a 0 or 1 case or some binary case. In this section or in this topic, we're going to focus on binary outcomes of 0 or 1. There is an additional version of logistic regression that we call ordinal logistic regression that allows you to deal with cases where there were multiple categories in the outcome, slightly more complicated. So here in this chapter, we'll just focus on the case in which the outcome is binary, 0 or 1. Okay, so the goal of a logit regression, or logistic regression, that's synonymous by the way, is to find a function of the predictor variables that relates them to a 0 or 1 outcome. So instead of a quantitative outcome variable y, we are going to come up with a function that's called the logit. The logit, which we'll explain more, can be modeled as a linear function of the predictors. That's what will make it useful and nice. The logit can be mapped back to a probability, which then can be mapped back to a class. Now, let's look at the first step. Remember, in most classification algorithms, there's most algorithms where the outcome is a 0 or 1, what we really are getting is an output that's a probability between 0 and 1. And so this is part of the motivation behind going towards a logit. Let me talk about this. So suppose that we were going to model P as a function of a linear equation. Remember, it is nice to be able to express things as linear functions. It makes the modeling more simple. But in this case, we run into a problem. And the problem is simply this. If you look at this equation, x can be any sort of predictor. And what if we have x values that are negative? Or what if we have x values that are very high? We would end up with a probability outcome that becomes either negative or goes way beyond the value of 1. If x1 becomes very large, p will also become very large, and we don't want that because we want a probability that stays nicely in between the values of 0 and 1. So we need to make a fix. And the fix is this. If we write P in this format, what we see here is that no matter what value, remember E is a number, is a natural number, 2.71, so forth. If you type exp in parentheses 1 in Excel, you will see that. And no matter what the values of x, no matter how far negative or how far positive for any of these values, this entire equation will stay between 0 and 1.